Okay, yeah, now we have 4:40 minutes. Okay. Excuse me. Okay. Where is my screen? Okay. In this section, as I mentioned, I will cover the regression because this is more important. I want to get it done within an hour from now. And so you can start to work on your project and work on it with your partner. All right. Okay. In this section, we will cover linear and multiple regressions. Okay. Let me mute your video. Okay, good. Yeah, whenever I'll mute you all so that I won't have background noise. Okay, right now this section we cover regression, mainly on multiple regression and logistic regression. So for that, you need to download the, I give you options to do it in Excel and R. Okay, I will send you all these material to email to you. All right, then what you need to do is to go to real statistic first, to go there. Okay, when you open the PowerPoint I'll send to you, I'll click on the real statistic, which I am sending it to the chat room to you as well. Okay, it's called real statistics .org.com. Okay, then you click on that link. Click on the free download. You can free download. Actually, free download here. The resource pack. You can also click on the example workbook as well later yourself. And so, and depending on whether you are if a Windows user, you click on that. Hopefully you have Excel like a 2013, 16, 19, and so forth. You click on that to download it. Okay, and so you will see it there. But and then if you are Mac user, you click on here. Click on Mac. Okay, click on Mac user. It should be Mac. Okay, if you're a Mac user, then you should be able to find Mac right here. Download it here. Click here to download, and I'll explain for Windows user first. Okay, for Windows user, and then you click on open your Excel, click on File, click on Options, Add-ins. You should see real stat here, but if not, then you need to do this. You need to do this. You go to the real stat. Okay, I mean you go to your this folder, program files, and / Microsoft Office root Office 16 library analysis, and real stat. You copy and paste it over there. Copy and paste it over there. So the file you download is over here. Download. You go to where you download, copy copy it, and go to your Windows. Go to your Windows where you have program file, program. Windows. Under Windows, okay, under your Windows, you have program files. Mine is x86, and go to Microsoft Office. Go to Office 16 root, and then Microsoft Office 16. Then look for library, the library where you see you can click on analysis and then paste it. So rheostat will be in there. Okay, so you see the folder is like that: programs, file, Microsoft Office, root, Office 16, library, analysis. And then you will see rheostat there, and then click on go, and rheostat will become an option, and check on it and click on OK. You will have it as under add in, you will see real statistic there. And the reason why you need to install it is because the regression under REG, the regression functions are all here. You will need the multiple linear regression for the first assignment, I mean part 1 of the project 3, and you will need the logistic regression, multiple logistic regression. Okay, those are 2 parts of your project 3 that you will use. Okay, otherwise you can also use R, which I will also send a file to you with link in there. You can explore. All right. Okay. So let me click on. Okay, and then for the Mac user, you just when you download the data set, you execute it. Okay, you download it, and you execute that file. Okay, I can't execute in mine, but you execute it. And under, I think it's under tools, you will find the tools, and tools, and under tools, almost at the bottom of the drop-down menu, you will see add-ins, Excel add-ins or complémentaire. Then you click on it. You will see the after you execute your rheostat Mac version, you will see that option and check on it. Then you will have it installed, available for you to use it as a Mac user, right? Not hard. And then you could excuse me. And then you have to click Control M. Okay, Mac user has to click Control M. Okay, so after you install it, okay, you execute the rheostat file and install it in Mac, and then hit the Control M. We'll see it. Okay, so you will see it now. All right, so from here we can move on for your analysis. Now, with that, you have it, and you will see these functions in there. You see these functions, a lot of functions, descriptive statistic. And even if you use a descriptive statistic, you will be able to generate many functions for you to use, even for project one. For example, if I randomly plug in the numbers here, and for example, randomly, and I use real statistic, I use descriptive statistic and normality, which I mentioned in previous slide, the normality probability chart. And you click on the box plot, outliers, QQ plot, dot plot, outliers and missing, and so forth. Okay. Then you click on here, select the range of data, and your output will be from D2. Okay. Let me see what happened. Do it again. Yeah, select this. That should be dot plot, QQ plot. Okay, what happened? Commonly occur when code is incompatible. Yeah, I have no problem yesterday. Why? Yeah, you can try it yourself. I just want to give you column heading. Oh, you don't have column heading. We don't have column heading. Okay, so that. Okay. Why output is D2? Yeah, I still was able to use it yesterday. Anyway, you give it a try, or okay. Do I plug in something wrong? Okay. Anyway, let me do it again. Let me give it a try again. Okay, let me do it again. Add in descriptive statistics. Okay. And then why? Anyway, I was able to do it yesterday. Still showing my student in my class. Maybe here output. Let's put it here. Oh yeah, maybe I didn't change the output here. Okay. That is a little bit weird. Anyway, I will let you try. I have no problem yesterday. Now I have a little bit problem. Oh, the error number one is incompatible with the version. Why? Sorry. You I'll let you try out yourself. Okay. Yes, I was still doing this yesterday. A little bit weird. It should be. Let me do it again. Included with there's no data. That is weird. Anyway, I was able to use it yesterday, but I some problem here right now. But you give it a try, okay? You should be able to do it because sometimes I just need to reset my computer. Okay. Anyway, you will, if you do that, you will see the result pops up and so forth. Give it a try. The first couple pages are about the installing it. Okay. And you can also download the regression examples. Okay, regression examples to take a look how to work all those examples and to get a hang of them. All right. Oh, it's taking too much time. Okay, let me. One second. Okay. I have to. No, it's not allowing me to move my to skip. 1 second. Okay. There is a little bit problem with my computer today, but don't worry. I can get out of it. Delete. Okay. I cannot change my page right now. A little bit weird. 1 second. 1 second. I got my screen was frozen. Let me. Okay, maybe let me and some in the R Excel in the Excel. Okay, see if this okay, maybe now it should work. Okay, yeah. I'm sorry. Okay, so you download it yourself. Okay, these are more functions as I mentioned. On the rec, you have the linear regressions and multiple regression, logistic regression, and so forth. And you have real statistics software capacity. These, if you click on all the options in the menu, you will see there are a lot of statistical functions in this real statistic, and that's why I ask that you install it because it's free, and there are more than you need for now, and it should suffice for you to use for quite a while down the road, even including what K-means cluster analysis, okay, which is a useful method in data mining. So this is a good tool. Okay, now talking about linear regression, we in the previous previous classes we only focus on the univariate data. And univariate data means that we only observe one variables at a time. For example, I ask how much what's your monthly income. Okay, so your monthly income is a variable, and I only observe one variable from each subject, which is each student or each person I ask is just income. That's univariate. But if I ask your degree as well, which is categorical, bachelor degree, master degree, or PhD degree, right? Then I measure two variables at a time, and normally degree of level of education will affect the income level as well. So there is kind of correlation between these two variables, a kind of relationship. That's what we study here from such a bivariate data. When there are two variables, we call it bivariate. And when there are more than two variate, we call it multivariate data. For example, So linear regression, simple linear regression only focus on one independent variable and one dependent variable. The example here is, well, dependent variable will be life expectancy, and the independent variable will be the number of cigarettes one take per day or per week, and so forth. Okay, so as you can see from the graph here, is kind of a relationship, negative correlation here. The more cigarette you smoke, the less life expectancy you have. Okay, so, and this is for linear regression. But okay, we'll cover the multiple regression after we finish this. And we also have exponential regression, where to address the issues between two variables which exhibit a kind of exponential relationship, okay, as you can see from the data here, that cannot be properly addressed by this correlation, by this a straight line. Okay, so we use an exponential equation. Okay. Okay, and there are also another way to do it, which is we use natural log for variables on both sides for your data. Okay, and we call it log model. And this model is handy when the relationship is nonlinear in parameters, because the log transformation generate the desired linearity in parameters. So you can see from here, this is there exhibits a kind of non-linearity, but through transformation, we turn that to linear relationship, and so we can describe the two log transformer data by a linear relationship. Okay, so that is univariate data, the simple linear regression. We also look at the exponential and log normal to send the transforming the data. Okay, now, but in the real world situation, multiple regression is more useful, because in the real world, for example, what affected your income? There are multiple factors, multiple variables, and not just your education, but also your age, and maybe your gender, and maybe how many languages you speak, and maybe how many, your GPA, for example, you name it. So multiple factors, multiple independent variables affecting a dependent variable. Okay. Yeah. Another example would be, okay, what's a monthly saving amount for a French family? Okay, of course, then the first independent variable were monthly income. The more you make, the more money you have to save each month. And also have to do with the number of members in the household. How many, if it's a big family, maybe they have fewer to save. And that also has to do with other factors. Okay, so it's a multiple regression. Okay. Okay, there are multiple factors that predict the outcome of an event, and the price movement of the mobile company depending on more than just the performance of overall market. The other predictors, such as price of oil, interest rates, price movement of oil futures, and All these can affect the price of XOM and the stock prices of other oil companies. So we have more than 2 variables to address the problem, and we call it multiple regression. So in the end, for multiple regression, you will form a formula in which you have the coefficients along with these parameters in that equation. Okay, so in this case, y may be the monthly saving amount, and you have beta 0, which is a constant, and beta 1 another constant, and x1 may be household income, beta 2 may be the number of families in the household, and then number 3 may be if they own a house, right? And number 4 maybe do they have a car, yes or no. So as you can see from this example, the dependent variable is continuous, because there's a monthly saving, continuous variable, but the independent variable may include continuous random variable, and also independent, and also categorical variable as well, because we talk about having a car or having a house or not. That's a yes or no question. So there's binary, as binomial variables. Okay, so a good combination of it will be in different type of variables will be included in your multiple regression model. Okay, and in that kind of multiple regression analysis, you will end up with the model having the ANOVA table on the right-hand side. And based on the ANOVA table on the right-hand side, you will be able to give an overall, let me see. Yeah, I think the one on top, they are different questions. Okay, these the first table on the right, on the top, on the bottom, they are different cases, and the result on the left hand side has to do with the one on the right hand side top. Okay, so and you can see that the price has to do with color, has to do with quality. And you can see the coefficients come from the table on the right. And the overall fitness of the table is what? 0.000497. It's a very fit model, and you can see where it's a R square and adjusted R square. They are both very high. So this is a good fit. Okay. Excuse me. And on the lower hand, lower right, you can also see another example showing different another model. Okay, what you need to look at. Okay, in multiple regression analysis, what you need to look at is what? To determine which variable is more important is through using the p-value. Okay, look, what if let's say if we want to ask ourselves, okay, are the model with 3 variables? You see, we have 3 independent variables, x1, 2, 3. Excuse me. Is a model with 3 independent variables the best model, or should we drop a few of the independent variables? Right? But then how do you determine that? The way to determine that is to excuse me, is to look at the p-value, and you can see here the p-value. The biggest p-value is the crime. Okay. So in the model up there, all the p-values look small. Of course, intercept is a little bit big, but we usually keep the intercept. Excuse me. Okay. Again, it's saying that we have 10 more minutes to be cut off. So, but don't worry. Once we cut off, we will get back in, and we should still have like a. After that, we should still have like a 15. Excuse me. 15 to 20 minutes to finish up. Okay, so once it's cut off, come back in. Okay. All right, so we have a p-value here. So what you need to do is to drop one that has a smallest p-value. I mean, sorry, the biggest p-value, and then see, and then also check the adjusted R-square. Okay, this is very important. This part is important for you, for your model. In your project 3, you should find a file, a data set, okay, with more than 2 independent variables. The more the better to start with, and then verse 1 dependent variable, and on which you can apply this multiple regression. And then you go through the step of kind of like a stepwise screening out use this independent variable, so to say, then to identify the best fit model. So how do you identify the best fit model? There are two ways. One is called backward stepwise regression. Backward stepwise regression is that you first include all the models, all the independent variables in the model, but then like the one in the lower right, crime may have too high a p-value that's bigger than 0.05. Is 0.5, right? 0.529 is much bigger than 0.05. So what you do is you may drop this crime, and then what? And then come up with see if the adjusted R-square increase or not. Why we don't just look at the R-square? Because R-square will always increase if you add every time you add the independent variable, regardless is significant or not, it will always increase the R-square. So R-square will always increase if you increase an independent variable. Although it's not very significant, it's not very useful in explaining away the variability, it will still increase a little bit of the R-square. So we look at the adjusted R-square. What adjusted R-square here? Let's turn to the next one. Okay, look, this is an adjusted R-square formula, and and it's adjusted from R-square. And look, P is the number of predictors. So in the previous case, you have 3 predictors. But you know, every time you increase, if you increase the P from 2 to 3 to 4 to 5, depending on your data set, R square adjusted will impose some penalty on it, because look, if your P is large, if you increase P, this n minus P minus 1 will become smaller, because it's in the you n subtract a bigger number. And then if this is smaller, this thing will become bigger. This will be bigger, but it will still be positive. So bigger positive number subtracted from 1 will make R square adjusted lower. You got that? So unless R square increase significantly, otherwise it will not. It will decrease the adjusted R square. In other words, it penalizes any random addition of independent variable to make sure that that your model is the best fit model. All right. So this is an important criteria in your multiple regression. When you build your model, this is how you select the best fit model. Okay. Another example is that look, you see here we have R squared, where R squared adjusted, and you can see not always if R squared will always increase when we increase the number of variables, but the adjusted R squared will not always increase. It will reach the maximum when there are 3 variables, but will decrease when you have the 4th and 5th variables add in. You got that? So that's why you look at R adjusted R squared for choosing the best fit model, along with the p-value. P-value tells you which one to drop, and then but then for the overall model, you look at adjusted R squared. So let's go back to this question. If you use a backward stepwise regression, that means you include all the independent variables in the model first. Then you drop one out at a time, like you drop crime out because it's the biggest p-value. Then record the R squared adjusted R squared value, and you can also keep that crime in the model and then drop white out and see how the R squared changes. And then you can also keep the white and crime and drop infant more out and see how that affect the adjusted R squared. So you do that for all 3, one by one, and see if then you will see which one will give the highest R squared, and then we will keep that model. Suppose crime should be out, and then you keep infant mortality and white. Then then 2 in the model. Then you continue to check when you only have 2 in the model, then drop white out and see what will happen to the adjusted R squared. And then keep white and then drop infant more, and then see what will happen to adjusted R squared. Then you will see, okay, maybe dropping more variables out of the model will not decrease the adjusted R squared anymore, and you will keep the 2 independent variables in the model and say that's the best fit model. In other words, you try different combinations, one independent variable in the model, 2 any combination of the 2 out of the 3 in the model, you will be able to find a maximum adjusted R squared. Remember, the higher the adjusted R squared, the better. And so given that you have 3 independent variables, but not all 3 are influential, you only choose maybe 2 or 1 depending on the result that you see in adjusted R squared and p-value. Okay. All right. So this is an important criteria that you that you will follow. Okay. We will have 1 minute before we got cut off. Then make sure you come back on. Okay. We will have another like 15 minutes also to finish. 20 minutes also to wrap up this important session. All right. So you will know how to work on your project. Okay. Maybe in a few seconds it will be cut out. So come back in. Now we come to see logistic regression. Okay. Why logistic regression? Because when the